Have you ever seen a jar of kimchi start to bubble and fizz all on its own, without anyone touching it? It looks almost alive, and in a way, it is. That jar is a tiny, self-running chemistry lab, and today we are opening it up. In this video, we will walk through 8 things that explain exactly how kimchi ferments. From the moment the vegetables are salted to the day the flavor turns sour and tangy, every step is driven by invisible microbes and simple chemistry. No magic, just science. Number 1, it all begins with salt. Before any fermentation can happen, the vegetables are soaked in a salty brine or rubbed with salt. This is not just for flavor, it is the very first control step in the whole process. The salt pulls water out of the vegetable cells through a process called osmosis. Water always moves from where there is less salt to where there is more, so it flows out of the crisp leaves, leaving them soft and pliable. That is why salted cabbage wilts and bends without breaking. This salty, low-water environment does something important. It welcomes the microbes we want and holds back the ones that cause rot. Only certain salt-tolerant bacteria can thrive here, and those are exactly the ones that make good kimchi. Number 2, the bacteria are already there. You do not need to add any special starter culture to make kimchi. The helpful microbes are naturally living on the surface of the fresh vegetables from the moment they are picked. These microbes are a group called lactic acid bacteria. They live quietly on plant surfaces in the field, waiting for the right conditions. When the vegetable is salted and packed away, their moment finally arrives. Because the bacteria come from the vegetables themselves, this is called wild fermentation. Every batch carries a slightly different mix of microbes, which is one reason homemade kimchi can taste a little different each time. Number 3, the secret is a world without air. The lactic acid bacteria that make kimchi work best when there is little to no oxygen around them. This is called an anaerobic environment. This is why kimchi is packed down tightly and the vegetables are kept submerged under their own brine. Pressing everything below the liquid pushes out air pockets and blocks oxygen from reaching the microbes deep inside. With oxygen out of the picture, the spoilage molds and bacteria that need air cannot grow well. Meanwhile, the lactic acid bacteria, which do not need oxygen, are free to multiply and take over the whole jar. Number 4, this brings us to the main event, lactic acid fermentation. The bacteria feed on the natural sugars found inside the vegetables. As they eat, they release a compound called lactic acid. That lactic acid is what gives ripe kimchi its sharp, sour, tangy taste. The longer the bacteria work, the more acid builds up, and the more sour the kimchi becomes. Fresh kimchi is mild, while old kimchi is intensely tangy. This same process is behind many other fermented foods, like yogurt and sourdough. In each case, friendly bacteria turn sugars into acid, transforming both the flavor and the texture of the food. Number 5, as the acid builds up, the chemistry of the jar changes. Scientists measure acidity with something called pH, and as more lactic acid forms, the pH steadily drops. The kimchi becomes more and more acidic. This rising acidity is not just about taste, it is also a form of preservation. Most harmful bacteria simply cannot survive in such a sour environment. The acid acts like an invisible shield protecting the food. This is the clever combination that has kept kimchi safe for centuries, salt at the start, then acid from fermentation. Together they create conditions where spoilage organisms struggle, but the food stays edible for a very long time. Number 6, now we can finally explain those mysterious bubbles. Some of the lactic acid bacteria do more than make acid, they also release a gas called carbon dioxide as they feed. That gas is what you see fizzing in the jar. As carbon dioxide builds up, it can make a sealed jar swell or hiss when you open it, almost like a bottle of soda. This is exactly why many people burp their fermentation jars, gently releasing the pressure so nothing overflows. If you are enjoying this deep dive into the hidden science of everyday food, take a second to subscribe so you do not miss the next one. Coming up, we look at the living bacteria that survive all the way to your plate. Number 7, many of the bacteria that ferment kimchi are still alive when you eat it. Living, helpful microbes like these are often called probiotics. In fully fermented, unheated kimchi, they are present in large numbers. Our digestive system is home to trillions of bacteria, sometimes called the gut microbiome. Fermented foods are one way people add more of these friendly microbes to that inner ecosystem, alongside a balanced diet. There is one catch worth knowing. Cooking or heating kimchi to high temperatures kills most of these live bacteria. So a hot kimchi stew still tastes wonderful, but it no longer delivers the same living probiotics as the raw version. Number 8, the last big factor is temperature and time. Fermentation is not a single event, it is a slow journey. How warm the kimchi is kept, and for how long, completely changes the final result. In a warm room, the bacteria work quickly and the kimchi turns sour in just a few days. Kept cold, the same jar ferments slowly over weeks, developing a deeper, more balanced flavor. This is why cold storage is used to slow things down. Over time, different types of bacteria take turns dominating the jar, a pattern scientists call microbial succession. Each stage adds new layers of flavor, which is why young kimchi and aged kimchi can taste like two different foods. So let us bring it all together. Kimchi fermentation runs on 8 things: salting and osmosis, wild lactic acid bacteria, an oxygen-free environment, lactic acid fermentation, falling pH, carbon dioxide, living probiotics, and the balance of temperature and time. What looks like a simple jar of vegetables is really a carefully balanced microbial world. Every bubble, every sour note, and every crunch is the visible result of chemistry that people learned to guide long before microscopes existed. If you learned something new today, tap like and subscribe for more deep dives into the hidden science of the food we eat every day. And tell me in the comments, which of these 8 steps surprised you the most? Thanks for watching.